Sum and difference of cubes. This is a method for factoring polynomials. And what is factoring? That means breaking something up into things that multiply to give you the thing that you started out with. So when do you use this particular method of factoring polynomials? Well, first of all, you have to have a binomial. So that means two things, two terms that are separated by a plus sign. Something here plus something, or minus, because it's sum or difference. And second, both terms have to be perfect cubes. Here's some examples. Each one of these are binomials. They all have two things, 1, 2, 1, 2, and then all of this is 1, and all of this is 2. They're all separated by pluses or minuses. And they're all perfect cubes as well. So 8, for example, is 2 cubed. X cubed is obviously a cube. A cubed is a cube. 1 is just 1 cubed. 1 to the power of anything is 1. 125 is 5 cubed, and 1,000 is 10 cubed. And even works with the a to the 6 and a to the 9, because a to the 6th is a squared and then cubed. So it'll work anytime you have a letter with an exponent that's a multiple of 3. b to the 9 is b cubed and then cubed. It's kind of a double cube. Now here are the two formulas for the sum of cubes and the difference of cubes method for factoring. If you're required to memorize these, I'll give you a few hints. Now the first thing you might notice if you look at these two formulas is that both of them have the letters in the same place. The xy, x squared, xy, and y squared is the same in both of them. What's different is the signs in between them, the pluses and minuses. So the way I remember this is that the first sign is always the same as what you started out with. So this one is the same as this one over here. If you're using the sum of cubes method, the first one will be a sum. This one is always the opposite here. And the last one is just always plus. So you'll see it's the same down here. Same, opposite, plus. Same, opposite, plus. That's how you can remember the signs, and then you just have to remember it's always x, y, and then x squared, xy, and y squared. Kind of makes it symmetrical. So I'll show you my method for doing the sum of cubes, and it also works with the difference of cubes factoring. The first thing is figure out all the things that go into the formula. So what are the x cubed, the y cubed, the x, the y, the x squared, the x times y here, and the y squared that goes in. Figure them all out separately, then substitute them in, and then you're done, usually. But you should check to make sure that it's factored completely. That should always be the last step in a factoring question, because they always want the answer to be factored completely. There might be a way you can factor it more with a different method. It's possible. Now here's an example. We have to factor the polynomial 8a cubed plus 27. And you can see this is a binomial. There are two things. They're separated by a plus, and they are both perfect cubes. So I'm just going to name the 8a cubed the x cubed from the formula, and the 27 will be the y cubed. And I'll write the formula over here just as a reference. X cubed plus y cubed equals, then it's x plus y because it's the same, then x squared minus xy, minus is opposite, plus y squared, same opposite plus. So now you think about which values are the x squared, the xy, and the y squared, and so on. Actually start with the x cubed. So the x cubed from the formula, I already said, is turning into 8a cubed. And y cubed is turning into 27. So the first part was already done for us. It's already in the question. Now what is x? We know x cubed is 8a cubed. So what do you cube to get 8a cubed? Well, 2 cubed gives you 8, so we'll have 2. And a cubed is just a cubed. So x should be 2a. And just to show you a bit more of where that comes from, you know that if you cube 2a, the whole thing, you get 8a cubed, because you cube the 2 and the a separately. Now y, so we know y cubed is 27, that means y has to be 3, because 3 times 3 times 3 is 27. Now what's x squared? it'll be 2a all squared. So that means we square the 2, it's 4, and then a squared is just a squared. And then what's y squared? It'll be 3 squared. 3 times 3 is 9. Now, the last thing is just to find x times y. So x was 2a, y is 3, so 2a times 3 is 6a. Now we know everything. So here's everything we just figured out, and all that's left is to substitute it all into the formula. So we start with the x cubed, which we turned into 8a cubed, and y cubed was 27. So 8a cubed plus 27 equals x is 2a, y becomes 3, x squared becomes 4a squared, minus x times y over here, that's 6a, plus 9. And that's it. That's the answer. You can check to make sure there aren't any ways you can factor this, just to make sure that it's fully factored, but there aren't. So neither this part in front nor this part can be factored anymore. Here is another example of factoring. We're asked to factor 64x cubed minus 1. Now, first of all, what method do we use? There are two things, and hopefully you can see they're both perfect cubes, because 64 is 4 cubed. 1 is just 1 cubed. X cubed is obviously a cube. And it's a difference, because there's a minus, so we're going to use the difference of cubes method. So I'm going to write that down. X cubed minus y cubed equals, and remember it's the same sign coming next, x minus y, then it's the opposite sign, so x squared plus xy. The last one is always plus, so plus y squared. Now I start by figuring out the first two things there, the x cubed and the y cubed. So x cubed, and I always put these little arrows, because it's not, x cubed isn't equal to 64x cubed, but that's what I'm substituting for it. Now, y cubed is going to turn into 1, because that's the second number there. I don't have to put the minus in because it's part of the formula. So next I figure out x, that's the next one in line anyway. So what do you have to cube to get 64x cubed? And the answer is 64 is 4 cubed, and you have to put that x in there. If you cube this whole thing, you get 64x cubed. And the y is just going to be 1. Now x squared, just take what we just figured out, the 4x, and square it. So it'll be 16, that's 4 times 4, x squared. And y is going to be, or y squared rather, is going to be 1 squared, which again is just 1. And the last thing we need to figure out, I'll put it over here, is x times y, from right here. So that is turning into this one, 4x times 1. So it'll just be 4x. Now I'm going to substitute it into the formula down here. So we start out with x cubed, 64 turns into 64x cubed, and minus 1 equals 4x, that's the x, minus 1. So look up here, that's what I'm substituting from. X squared is 16x squared plus xy is 4x plus y squared was just 1 again. So that's it. That's that thing factored, because you can't factor it anymore. Now here's yet another example of factoring using sum or difference of cubes. This one doesn't look like you can use the sum or difference of cubes. There are two things here, but 16 isn't a perfect cube and neither is 250. So what you have to do is factor it out using a different method first. You may notice that there are common factors in each one of these two terms, so you can factor those out. A common factor between 16 and 250 is 2, so I can put that in front. And also, you have a terms in both of them, so I can put down the lowest power of a that you see, a to the 4. So after that comes, you divide each of them by the numbers in front. So 16 divided by 2 is 8. The a to the 4 here just disappears. It becomes a 1, and you're left with just b to the 6. Plus, and then I divide the 250 by 2 as well, and that gives you 125. And a to the 10, I'm going to divide by a to the 4. You end up subtracting the two exponents, so you have a to the 6. So we've already factored this using one method, but hopefully you can see we're not done yet, because what's inside the brackets here is now a sum of two cubes. So I can factor this more now. So I'll write down the formula over here really quickly. X cubed plus y cubed equals x plus y times x squared minus x times y plus y squared. Squared. Okay. Now I take the two things here and substitute them in. So the x cubed from the formula is turning into 8b to the 6th. And the y cubed is turning into 125a to the 6th. Now x is just the cube root of what we started out with here, so that's going to be 2b squared. Now can you see why that is? If I take 2b squared and cube it, all in brackets, you get back to where we started here. The 2 cubed becomes an 8, the b squared cubed becomes 6 because the 2 and the 3 are multiplied. Same thing for y. So y is going to be 125, so we have 5 cubed gives you 125, and a squared cubed gives you a to the 6th. So that's y. Next, x squared is going to be what x was, and just square it, so 4b to the 4. Y squared is 25a to the 4. And the last thing is just x times y. So that's going to turn into 10a squared b squared. Now all that's left is to substitute that back into the formula. And I'm not going to write out the x cubed and the y cubed yet. I'm just going to put the final answer. So we still have the 2a to the 4 in front. Don't forget that that's there. And instead of the 8b to the 6th plus 125a to the 6th, we have this part, x plus y times x squared minus xy plus y squared. So I'll just substitute that in all at once. So it'll be 2b squared plus 5a squared, and then you have 4b to the 4th minus 10a squared b squared plus 25a to the 4th. And that's it. That will be the final answer. You can't factor that anymore. Thank goodness. Now it looks complicated, but really it's not so much. One of the hardest parts is just identifying that you have to use this method, the sum of cubes. Then it's just step by step. Figure out what all the things in the formula are and substitute them in. And the answer is big and long and ugly, but it still works.